In 2018, the tennis racket industry was worth a staggering $352 million. Today, it's dominated by companies such as Babola, Head, Watson, or Yonex, and statistics show that it's a grossing industry amongst all age groups. From the young adults taking part in a weekend matchup to the elderly using it for its immense cardio benefits in countries such as the United States, Germany, or France. As the industry expands, so can we at Racket Science by selling a high-end product for confirmed players, which is not only environmentally friendly, but relieves a lot of stress on the joints in the shoulders and arms.
We've asked thousands of players what they think makes a great tennis racket. 3 things stood out: power, control over the ball, and vibration absorption.
It's been over 30 years now since graphite and carbon fiber composites took over the racket market, replacing over the heavier and stiffer metal rackets. However, these modern-day rackets offer low recyclability. Carbon fiber composites and graphite can only be recycled into weaker objects and require extremely costly and complicated technologies. This is why at Racket Science we have decided to return to aluminum, with addressing waste as our major concern. We are extremely proud to introduce a hollow frame of graphene-reinforced aluminum produced through a liquid infiltration squeeze casting process. It has comparable strength to composite and offers flexibility for an exact precision on every shot. All this while maintaining the recyclability of the 6061 aluminum. Our calculations show that a nano with 13% graphene is 60% stronger than conventional aluminum. These numbers could go down to 2% graphene in low-stress areas such as the top of the head of the racket to maintain a competitive price tag.
The racket is produced through a 5-step process. First step is making that hollow graphene alloy frame.
For this, we use the lost wax method. A wax core in the shape of the racket is dipped into a slurry of silica which forms a ceramic shell around it. The wax is burnt out and can be reused for other molds. The ceramic mold is then used as a core in the molding process. Once the aluminium is melted in a crucible furnace, it is poured into the mold. Once cooled, the ceramic is cracked by creating vibrations of the frame and washed out with high-pressure water. The frame is chased and polished. The next step is drilling holes for the strings, yoke, and throat of the racket. The racket is held vertically in the middle of a drill which uses carbide spindles for high precision in finishing. The sharp edges and drilling imperfections are smoothed out in a sander. The third step is heat tempering to harden the aluminium and give additional strength to the racket. The racket is placed in a heated oven, then rapidly cooled in water. Once cooled, it is immersed in a sulfuric acid solution with an electric current to anodize it. This ensures that classy, shiny finish you want on the end of every stroke. The following step reinforces the frame and allows for further vibration damping through injected polyurethane foam. The frame is then heated and the foam's expansion adds strength to the frame. Finally, an end cap is placed, the brand decals are printed, and the racket is sent to quality control steps where it is subject to stress tests. Its balance, grommet holes, and aesthetic appeal are also checked. Along with the racket, we provide a slick core case made of bark from Portugal's great oak trees. Once the bark is harvested, the trees absorb up to 5 times more CO2. The cork is stacked for a week before being shredded into granules, which are poured into a mold where they are compressed to form the casing's shape. This is a no-waste process. Our goal is to produce 100,000 rackets a year for 1.5% of the market. With a production cost of £28 per racket and a retail price of $120,000, we produce a reliable, more durable, and less expensive racket than our competitors. That's Racket Science.